Okay, let's take a scenario. You have a kid right there. That's gonna be the dot. And he's holding a string, and on the string is a rock tied to the string. And he's twirling the string. So that's the velocity of the string. Okay? So if we draw it, here's the kid, here's the string, here's the rock, and this is the rock's path. Okay? Now, the circumference of the rock's path, in other words, the length of this line, of this circle, is 4 pi meters. Okay? Now, what we want to know is the centripetal force. So we want to find F of C. Alright? Okay. So, we need a little bit more information. The mass of this rock is going to be 1 kilogram. Okay? And the speed at which the rock travels, or the velocity, well, speed more accurately, is 10 meters per second. Okay? Alright. So let's find the centripetal force. Well, we know force equals mass times acceleration. And we know the centripetal acceleration equals v squared over r. V being 10 meters per second, and r will be determined from the circumference. So if we plug that into this, we know that centripetal force is going to be mass times v squared over r. Alright. Now we have the formula for centripetal force. Maybe we can find it. So let's do some work with the circumference to find the radius. Circumference equals 2 pi times the radius. In other words, 2 pi, which is a number, 2 times 3.14, 159, etc., is the amount of radius lengths or radians that there will be in the circumference of the circle. So, we're given the circumference is 4 pi. So, if we solve for r equals 2 meters. Alright. So, now that we have all the information we need, let's plug in. Fc equals mass, which is given 1 kilogram times v squared, which is also given. That's going to be 10 meters per second squared over the radius, which we just determined, 2 meters. So let's simplify. Fc equals 1 kilogram times 100 meters squared per seconds squared over 2 meters. Okay, that's the same as 1 kilogram times 100 meters squared over 2 meters, and the second squared can come right down here because it's divided from the meter squared. Okay? So this is 100 meters. This m reduces with this m. So 100 meters times kilograms divided by 2 seconds squared. Well, we reduce this to 1 and 50, and we get 50 meters per kilogram over second squared. Well, we know that the definition of a Newton is the following: the amount of force required to move 1 kilogram of mass by 1 meter per second. Okay? So, just in case you didn't understand that, let me say it again. One Newton is equal to the force that would give a mass of 1 kilogram an acceleration of 1 meter per second. Okay? So 1 kilogram, acceleration of 1 meter per second, and acceleration always seconds squared, so, or distance, or time squared. So here we have acceleration, here we have a kilogram, so this comes out to 1 Newton times 50, and the centripetal force is 50 newtons. The centripetal force, in other words, the force of tension on the string here is 50 newtons.